Hello, Reese. We are starting the notes for 1-8. We are doing operations on functions. Go away. Go away, you darn thing. Come on. Okay, there we go. All right, so operations on functions. We are adding, subtracting, multiplying, dividing.
Ew.
Yes, and then we're sticking functions inside of each other, which is called compositions. Okay, I made these up. F and G. If we're taking and we're doing f plus g of x, that literally just means you're taking them and adding them together. Now this is my favorite. X plus 4 plus x squared plus 6x. My Algebra 2 kids are really on the struggle bus right now. They're really on the struggle bus right now because they see that and they automatically foil because it's in parentheses. And I'm like, you're adding, silly kids. Like, don't foil, okay? They're foiling that every single time. So when you add, you combine like terms and you get x squared plus 7x plus 4, and that's it, right? If you're subtracting, f minus g of x, he is x plus 4. You don't have to write this down because we're going to do another example. But you're subtracting, and the thing that I will say about subtracting is just make sure that you distribute your negative through. So negative x squared, it'll be like minus 5x plus 4 is what you would get, right? Because if this is negative 6 and positive 1, right? That's what the minus would be. Now, only when you are multiplying, which will look like fg, right? That just means f times g, okay? If you have f open circle g, like it says fog, that is not the same thing. We're going to get to that, okay? That does not mean multiply. So this guy says multiply, not this guy. Okay, f composed of g does not mean that multiply. So here we're foiling x plus 4 times x squared plus 6. But it's my favorite thing when they look at this and they foil. And I'm like, no, don't do that. You're subtracting. No, don't do that. You're adding. They're right next to each other. That's when you foil. Okay, x cubed plus 6x squared plus 4x squared plus 24x. You don't have to write this down. X cubed plus 10x squared plus 24x. That's what he will look like. Okay, and then dividing, f divided by g. Pay attention to which one's on the top. Would look like x plus 4 over x squared plus 6x. If you can cancel, go ahead and cancel. But if you can't cancel, you literally just get to leave your answer like that. Can you cancel this x with this one? No. How's come? They're trapped. Like x plus 4 would have to be a whole chunk to cancel with like a whole chunk down here, but that does not take place, so you're literally going to leave it. Got it? Okay, add, subtract, multiply, divide. That's how it works. Okay, adding two functions. We are adding these together. We are taking f plus g, so this guy plus 5, the square root of 25 minus x squared, and I am adding 5 to it. Now,
We can take the square root.
Can you take the square root of this thing? So he's a difference of squares, right? Okay, so let's do that. Don't write this down. Just watch. Okay? If I factor him as a difference of squares, what's 25 minus x squared look like? 5 plus x and 5 minus x. So can I take the square root? Those aren't the same thing, right? 5 plus x is different than 5 minus x. So if I say, like, when you're taking the square root, you're saying what times itself gives me this?
Nothing.
Right? Nothing, because this isn't itself, right? Those are two separate things, right? One's plus, one's minus. So I can't take the square root of that, right? Because this is the difference of squares. One's plus, one's minus. If they both were plus, then we would have a thing, and it would work out. But it's not going to work. So what do I do?
Nothing.
Nothing. This is the answer right there. Because you can't put those together. You cannot take the square root of that first piece. Okay, he's a difference of squares. Right? Okay, next. All right, now we've got this stuff going on, okay? And they have some different things. Up here they said f plus g of x. So we were just leaving the function. Now they're saying m minus n of negative 2. So when everything's said and done, we plug in negative 2. We plug in negative 2. So I'm taking m and I'm minus n. So I take this guy minus this guy. That will look like 4x minus absolute value of x minus 3. Okay, can I do anything to simplify? No, so we're just going to plug negative 2 in. 4 times negative 2 minus negative 2 minus 3. All right, this guy becomes -8 minus, this is -5 in here. What's the absolute value of -5? +5, but then the minus is still there from the front, right? So that is -13. Got it?
Hang on. Oh, well, it's not one.
I like these.
Yeah, not too bad.
Hang on. Yet.
They'll get a little nasty, but not terrible.
Like the next one?
What?
Like the next
Yeah, P is not good.
He is not cute.
He's fine though.
You're not enough.
Okay, M is my first guy, so I have 4x, and this is times, right? Like the closed dot is times, okay? And then I have, so they'll either write it as MP or they'll put M like multiplication dot P, right? 1 over x plus 1, that is M times P. You can simplify if you want to, but actually, you know what? We really don't even have to. We can just plug 1 in at that point, right? So I plug 1 in here and I plug 1 in here. So 4 times 1 is 4. And this guy is 1 over 2. So what's 4 times half? 2. That's my final answer. Not so bad, right? Okay. P over n of 3. So, P is 1 over x plus 1. Over, I'm going to do a big over because we have fractions going on. N is the absolute value of x minus 3. So I'm just plugging 3 in. Oh, heavens. Oh, boy. So we're putting 3 in, right? 3 goes here and 3 goes here. You see something yet?
Doesn't work.
This is 1/4 divided by 3 minus 3 is 0. The absolute value of 0 is 0. So, what does that mean? No solutions because we cannot divide by 0, right? I don't care if 1/4 is the top answer. You can't divide by 0. Your bottom can't be 0. So gone. Good? Happy with that? Like not so bad, right? If they leave it as x, so if they say f plus g of x, you just write it as an expression and x will be in your answer. But down here when they say plug a number in, you'll just plug a number in and you will get a number as your answer. Got it? Or no solutions, right?
I think that's enough for today. We only have like 10 minutes.
Okay.
Any problems can be done.
All right, we might get done with this problem and that's it because we're finding domain now. Ugh. All right, ready? Here we're subtracting them. Okay, so I'm going to do A down here. So we have some room. Okay, A is going to go right here. We're doing G minus H. G is this guy. So I have 2x minus H is x squared minus 4x. There's a reason why I put him in parentheses. How's come?
He's dumb. Can we take an X out?
Because we've got to distribute the negative through, right? So I have 2x minus x squared plus 4x. Okay, let's combine like terms and let's see what we get. In order, he will go negative x squared plus 6x. That's my final answer. So I have found the answer. Find this and write the domain of it. Okay, so I have found the answer to that. Now I have to figure out what the domain is. Okay, in interval notation. Yes, in interval notation. Okay, domain. Do you remember how to do domain?
Left and right.
Yeah, if you're looking at a graph, you say like, where does he touch left and right, right? But if you're looking at an equation and not at the graph, what do you look for with domain? It's like what x can be and what x can't be. Well, what can't x be? Like, what do I have to worry about? What?
X can be anything.
We don't want to divide by 0, and we don't want to have a negative inside of a square root. So in this one, this is a quadratic function. Think about this in terms of a parabola. This is a parabola facing down and moved somehow, some way, right? So it's a parabola looks like this. Is he going to go forever to the left and forever to the right? Sure, because he doesn't have any of these things going on, right? So his domain is all reals, but in interval notation, which is what they want. Negative infinity to positive infinity. So this is my domain, right? Unless he has one of these things happening, he is totally fine. Good? Beautiful. Beautiful. B.
So domain is all reals?
All reals. Or negative infinity to positive infinity because they want it in interval notation. Okay? All right, B. What operation are we doing in B?
Times.
G times K. Yep. Of x. So we're finding that first. All right, G is 2x times the square root of x minus 1. How do I do that? Can we put the 2x in underneath it here? No, so he is literally just 2x square roots of x minus 1. Like, that's all I can do, right? That's the answer for that. I can't put them together, right? Don't put them together unless you can put them together. The domain. Here we have to worry about x being negative, right? Can x be 0? Or can the stuff inside of here be 0? Can you take the square root of 0?
Yeah.
What?
Can you go back to the rules?
Yeah, the rules. There's the rules. You can't divide by 0 and can't have a negative inside the square root.
Okay, thank you. Just make sure he's not a negative.
So we don't want him to be negative.
So he can be.
Okay, so here's what I do every time. I set x minus 1 equal to 0. If x minus 1 equals 0, x equals 1, right? Okay, now I'm going to slap him on a number line. If I have 1 here, over here, let's test the point like 0, and then let's test 2. Which one can I have and which one can't I have?
You can't have 0.
If I plug 0 in, I'll have negative. I don't want that to happen. If I plug 2 in, I'll have 2 minus 1, which is 1, and I can have that, okay? So that means for my domain, x has to be greater than 1. Can it be equal to 1?
Yes.
Yes.
If I plug 1 in, 1 minus 1 is 0. I can take the square root of 0. Okay, so there's that. Now, what does that look like in interval notation?
1 bracket, comma, infinity.
1 comma to infinity. It's going forever to the right. 1 to infinity. And bracket per n. That's interval notation. Okay? And you can use the graph to figure that out too. Right? Okay? What? Yeah, it's kind of a icky thing. Okay, good? How about that? Was that good? Oh, that was it? Oh, no, we got to see. C is division. We are dividing H and K. Okay, that's not too bad. K is on top. So, oh heavens to Betsy. All right, the square root of x minus 1. This one's going to be icky. H is the bottom. He is x squared minus 4x. Oh heavens. What can I do to simplify him?
Multiply with the x squared minus 4x up to the other side.
No, that's not going to help though.
Multiply by the reciprocal.
Because that's not going to do anything for
Can
me.
you square the top and
Nope.
the square on the bottom?
Nope.
Can you square the top?
What? He's almost a difference of squares except there's an x here. So that's not going to work.
Take an x out then.
I mean, you could, but where am I going to do with it?
I don't know.
When I take it out. Okay, let's do it. That's fine. We can take the x out because that's going to help me later. X minus 1, and we've got x times x minus 4, like that. Okay?
Now we need to
Now that would be nice if I could cancel him here, but I can't do that, right?
Square it. You need to top.
Nope, we can't do that. We can only square it, like we can only add in squaring it if it's like has an equal sign. Like if we're squaring the other side also.
So can we just do them like
Nah.
that?
But, yeah, we did. What?
We don't have an x.
Like that?
That's all we can do. We can't do anything else. You could technically leave them like this, but we'll pull the x out because that's going to help me later. Okay, now we have to determine domain. Which domain problem do I have to worry about?
Both.
Both of them. Ugh. Both of them. Okay, so for a domain, I know
It has to be 1 to infinity for the top.
I know from here that x has to be greater than 1, right? Or equal to 1. So I know from the top that x has to be greater than or equal to 1, but now we got to worry about the bottom as well, right? So if looking at this on a number line, I have 1 here, and he's a closed circle to the right. I know that's what my domain is. I cannot plug any of these numbers in that are lower than 1. That is illegal. I cannot do it, okay? Now, what also do I have to worry about?
The 4. Like the
I have a denominator, so I don't want this to be 0, right?
So it can't be 4.
So x times x minus 4 cannot be 0. Now what do I do?
Can't.
And x can't be 0 and x minus 4 can't be 0. It's like you're factoring, right? Like you're separating your two pieces. So x can't be 0, right? And if x minus 4 can't be 0, x can't be 4, right? You see how that works? Okay? It's like when you have two groups and you're setting it equal to 0. I saw my two groups. This equals 0, this equals 0, right? Yeah? So x can't be 0 and x can't be 4. All right. Now, here's the deal. If x can't be 0, 0 lives here, right? I can't have that. Well, we knew you couldn't have that to begin with, right? Because we know x has to be greater than 1. So now we know that there's an open circle on 4, right? Okay, so let's just look at this and let's put this into interval notation. Ready? Okay, we have this going on, and then we have this going on, right? We have two chunks, right? My first chunk is going from 1 to 4.
Bracket 1, comma 4, friend.
Yep, we have that going on, right? Okay, unioned with
Bracket 4,
paren 4.
friend.
Wait, colon trig.
Infinity.
That's what he looks
Can
like.
you get a second thingy like that?
So he breaks at 4 because there's an open circle at 4, meaning he can't touch 4. Does that make sense right here?
Yeah, we have to
Normally he was
say-
1 to infinity, but now we're saying he can't be 4 also. So we're just going to put a little break in there, right? What?
For the domain part, like we have x is greater than or equal to 1, don't we need like x is less than 4? Because it can't be 4.
But it can be greater than 4 also. So technically your whole domain is x is greater than or equal to 1 and x can't be 4. Right? But in interval notation, that's what this looks like. This is saying the same thing as that. Now x can't be 0, but if it's greater than 1, it's already not going to be 0, right? So we don't have to include the x can't be 0 part, right? That's what he is. Got it? Confusion? Little bit? Little bit. Okay, domains get icky, especially if they do both of them at the same time. Yikes. Okay? All right, we're gonna stop there. Let me go down to here.
We can go up to 32.
You can go up to 32. You're just awesome. You go up to so really 22. Connor's got to figure it out. You can go up to 22. 8 through 22. Start on those. There you go.
Can we usually
Questions before I stop the video?
You should have made us do 5, 6, 7, and 8.
What?
But it's okay.
I should make you do 5, 6, 7, 8.
You should have it eliminated some of the other ones.
Oh, you think so?
Okay, colon trig. Can I go to my locker?
Okay. All right. Okay, goodbye, Reese.
Right?